So, hi Nikita. So we are doing mole concept, and in order to understand mole, first let us understand what is a dozen and what is a pair. Okay, dozen basically means 12, right? You are aware of this, right?
Yeah.
Pair means two. So if you go to Walmart and if you go and buy or tell the storekeeper over there or somebody, some volunteer over there and ask them, okay, can you help me with 12 dozen apple? He'll be able to help you.
Yeah.
He'll be able
Yeah.
to pack. Why not?
Because 12 dozen is like 12 times 12, so like 144 apples. So,
Yeah, so Walmart will have 144 apples, isn't it?
yeah, but it'd be like hard to, do.
What?
And
Hard
it's
to
not
what?
like, it'd be like hard to like pack all the 144 apples.
Imagine that we are able to pack,
Okay.
right? So if you tell him 12 dozen apple, he will give you 144. You
Yeah.
understand that, right? If you ask for 12 pairs or 12 dozen of let us say pen, he'll give you 24 pens,
Hmm.
correct?
Yeah.
Because the number is fixed. 12 is fixed. Doesn't means 12 is known to everybody,
Yeah.
right?
Yeah.
So number 12 is known as dozen. Number 2 is known as pair. Correct?
Yeah.
Okay. Similarly, for chemistry, that mole is a number which is 6.022 into 10 raised to 23. Correct?
Yeah.
So what is mole? Mole is a number. Is that clear?
Yeah.
So it is just the way we count number of items when it is dozen and pair. We can count number of items if it is mole. But the problem with mole is that it's a huge number,
Yeah.
right?
Yeah.
6.022 into 10 raised to 23. That number is so huge that even Elon Musk and Jeff Bezos together, they don't have this much of money.
Mhm.
Does
Yeah.
that give you a feel of the number?
Yeah.
So together their wealth is not equal to this number, right?
Yeah.
So, but because this number is so huge, it is not used in our day-to-day life,
Yeah.
but we use it in chemistry lab. Okay.
Okay.
It is also represented as Na. Na means Avogadro's constant or Avogadro's number.
Okay.
So if you come across 1 mole, if you come across 6.022 into 10 raised to 23, or if you come across Avogadro's constant or Avogadro's number, all of these are telling you one story. That is, the number is 6.022 into 10 raised to 23, which is a huge number. Correct?
Yeah.
Right?
Yeah.
Now, because that's such a huge number, it is only used for microscopic entities like electrons, protons, neutrons, atoms, ions, molecules. So we don't use mole for macroscopic entities. For that, dozen, pair, that is more than sufficient.
Hmm.
But when it comes to microscopic entities, that number is like negligible. So you need a larger unit. Clear?
Yeah.
So dozen is a unit, pair is a unit, mole is a unit.
Okay.
That unit is telling you a specific number. Clear?
Yeah.
Okay. Do you know how to calculate molar mass?
Um, yes, kind of.
Kind of. Okay. Right. So molar mass is basically what? Each and every atom in the molecule you consider and you find out the weight of each and every atom that is present in the molecule. And then you do the summation of them. So whatever you get is the molar mass. For example, in this on the screen, that is ammonium phosphate. If you notice, there are three nitrogen atoms.
Yeah.
there are 12 hydrogen atoms.
Yeah.
There is one phosphorus atom and there is four oxygen atoms.
Yeah.
Nitrogen, I have taken the whole numbers. Nitrogen atomic mass is 14.
Yeah.
Hydrogen atomic mass is 1. Phosphorus atomic mass is 31. Oxygen atomic mass is 16.
Yeah.
Correct? If we
Yeah.
do the multiplication and summation, what we get is 149 gram per mole.
Yeah.
Correct? Can you
Mm,
do this? Can you write down this?
sure. Yeah. Like the number beside oxygen and the like yeah, like that,
Yeah.
like underneath it.
Yes, yes. Go ahead. Tell me. Ask your doubt.
Like you know how it says P and then bracket one plus is like oxygen? Like what's what's in the number beside that bracket?
Which one? This is this number.
No, like
Oh,
the
this
one
is
above,
6.
like the one above it.
Wait. I'll try to move the cursor here. Here.
No, you know like the number above, like yeah, beside that one, beside oxygen, like the other way.
This one. This.
No, no, the other, no, like
Here.
beside oxygen, like in the
This.
yeah, that one, that one.
That is 4.
Four, okay.
Yeah.
Put it down.
You done?
Yep.
Okay. Now, what is the significance of that? Let me tell you. Whenever you calculate the molar mass, okay, and if you convert that to gram, there is a magic that that number automatically comes to 1 mole.
Yep.
Okay.
Mhm.
So, are you aware of this?
Yeah. Just no.
Okay. So, what you should know that if you calculate the molar mass and you write that as in grams, so molar mass expressed in grams is equal to 1 mole.
Okay.
And now you know 1 mole is actually 6.022 into 10 raised to 23.
Okay.
Clear?
Yeah.
Okay. Now I want you to calculate the molar mass of carbon dioxide, water, and H2SO4
Okay.
and tell me the number. I'll be on mute. I'm here.
So for like on the first one you said like in bracket N and then beside in bracket 3, like how did you get that?
That, can you see NH4 3?
Yeah.
That means this 3 is multiplied to each and every atom.
Oh, okay. So okay.
So for carbon dioxide, how many carbons we have?
One,
How many oxygens we have?
two,
Yeah, that's it
okay.
then. It's a simple thing.
And how did the N become 14?
N become
Wait,
14.
wait. Oh wait, actually wait, never mind.
So that is the atomic mass
Yeah.
from the periodic table. Any difficulty?
I know that's all. I'm
No.
doing I got 44.
That's correct.
Okay. Should I do like the other two like right now?
Yes, please, because I want to know you're getting it correct. Okay. If you know how to calculate molar mass, the further part is extremely easy because it is just two formulas and solving them.
Okay.
Okay, it's very easy. This unit is extremely easy.
Okay. The other two. For H2O, I got 18, and then
Perfect.
for the other one, I got 98.
Perfect. That's good. Then next part. Again, I'll repeat myself. 1 mole expressed in grams. So molar mass expressed in grams is equal to 1 mole, right?
Yeah.
Okay. Now the next part is you should know how to convert mass to amount. So when we say mass to amount, mass is generally given to us in gram and amount is nothing but the mole. So the formula for that is N is equal to M over capital M.
Mhm. Okay.
Okay. So where N means number of moles, M is the mass in grams, and capital M is the molar mass in gram per mole.
Yeah.
Okay.
Yeah.
For the conversion, there are generally these triangles that are given in most of the book, right? So this is the triangle. So if you need N, it is M over capital M. If you need mass, then it is N into capital M.
Okay.
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 Any difficulty there?
No.
Okay, great. So next is we'll do the percentage composition later, but
Okay.
for now, just remember the formula that percentage of percentage composition of carbon dioxide, right? So it is
Hmm.
the mass of molar mass of carbon in carbon dioxide over molar mass of carbon dioxide. So
Okay.
basically, if you see carbon is 12,
Yeah.
right, and there is only one carbon, so it is 12 over 44 because you calculated the molar mass into 100. So that
Okay.
becomes a 27% is the percentage of carbon in carbon dioxide. We'll
Okay.
do this later when there is a need. For now, just let us skip it.
All
Okay,
right.
now let us try and do these problems. So first A, C, and E.
Okay.
Okay, so check the question. The question is calculate the amount. Okay,
Okay.
amount means moles
Okay.
of pure substance in each of the following. A 500-gram box of table salt. Table salt is sodium chloride. We are assuming that it is pure sodium chloride. You know the
Okay.
formula of sodium chloride?
Yep.
What is it?
NaCl.
Perfect. So can you calculate the molar mass?
Yeah. 63.
What is 63?
The molar mass of NaCl.
No. Why did you get 63? It is NaCl.
Um,
Cl is 35.5. Sodium is 23.
I accidentally was looking at argon. Wait.
Yeah, it should be 58 point something. 58.5. So you
Yeah, I
check.
got 58. Yeah.
Yeah, 58.5.
Yeah.
It is 35.5. What 35.45 in your on the
Yeah.
periodic
I was
table, right?
like on the periodic table. I was like looking at the one beside it.
Okay, no problem.
Yeah, makes sense.
So this is okay. Calculate the moles. Is this that you had missed in the school?
I think so. Yeah. I think this is what I missed.
Okay.
Yeah.
Okay, can you do C now? You got
Yeah.
8.56.
Yeah.
Can you do C?
Yeah. I got 56.
Sorry, yeah.
Yeah, I got 56.
Okay, 50, 56 for what?
For C.
For C, uh,
Yeah.
what is 56? The molar mass, right?
Yeah, molar mass.
Can you, okay, what about the moles? We have to calculate the moles.
Mm-hmm.
Okay, so molar, okay. The thing is, if you know the name of the compound, by default you know the molar mass. That is what is the assumption here.
Okay.
Yeah. So when they give you the name of the compound, that means you have to calculate the molar mass and then calculate the moles.
So the molar mass is calcium oxide.
Molar mass of calcium oxide, yes. How much is that? You said 56, right? That's correct. And how much
Mm.
is the mass?
Um, I don't know.
Here, 1 kg.
Oh, okay, 1 kg.
Yeah. So 1 kg is how many grams?
100. What?
Sorry? When,
1,000.
yeah.
1,000.
Okay. So kilograms. So whenever you see kilo as the term, kilograms, this K stands for 1000.
Yeah.
Okay. If it is milligram, this milli stands for divide by 1000.
Yeah.
Okay. Or the other way, 10 raised to 3, and this stands for 10 raised to minus 3. So there are two options that you can use.
Okay.
Okay.
Mm. Okay. Okay. Um. Okay, I understand it.
No, not able to do it.
No, I get it.
So mass is 1000,
Yeah.
right? And
Yeah.
molar mass is 56
Yeah.
gram per mole.
Okay.
So N is M over capital M.
Okay.
So
So
that is
then,
1000 over 56.
okay.
Did you do that?
I'm doing. Yeah. Wait, I need to get my calculator.
You need my help?
I don't know. I was just getting my calculator.
Okay.
17.8.
That's correct. Can you do E now?
Yeah.
So the formula is given over here.
Okay.
So the mass is 200 milligram.
Okay.
So milligram means divide by 1000
Okay.
grams, correct?
Yeah.
And molar mass for Ah, this is a big number, right? C13, H18, O2. So carbon multiplied by 13 plus hydrogen multiplied by 18 plus oxygen multiplied by 2. Can you solve this?
Okay.
Are you able to solve it, Nikita?
Yeah, so for the molar mass, I got 206.
Perfect. And
And
N?
for N, do I do like, so I do 200 and then like divide it by 1,000 and then
So
do
zero
I,
point 0.2 you will get right.
yeah, I got 0.2.
Yeah, use zero point 0.2 directly.
Okay, and then I
So
do 0.2 over 206.
yes.
Okay, I got 0.0009.
Is there any other number ahead of that?
Seven. Okay, 0.0097.
7 what?
08.
Okay. So the answer will be 9.708 into 10 raised to minus 4 moles. Why? Let me explain you. Can you see how many figures are over here?
Yeah,
Four
just like this.
significant
Just
figures.
one sec. I need to write it down.
Yeah. So because your question has four significant figures, your answer has four significant figures.
Okay.
Okay.
Hold on, just one sec. I'm writing it down. Okay, so wait, so like, why is it like 7.08 times and the point?
9.708. So that is what I'm coming to.
Yeah.
Can you see
Okay.
there are three significant figures over here?
Yeah.
Okay. So if the question has four significant figures, then your answer should be in four significant figures. If you
Okay.
notice, there are three significant figures here. Answer is in three significant figures. Three
Yeah.
significant figures. Three significant figures. These are three significant figures again. Three significant figures.
Okay.
Three, three. Okay.
Okay. Yeah. Yeah, I
But
get it.
if you would have written this 0.009, okay,
Yeah.
then it would have been how many significant figures? Only three.
Yeah.
So that doesn't make sorry, anything before after decimal, that is not so 9.708 into 10 raised to minus 4 is the four significant figures.
Yeah.
Okay, done that.
y- Yeah.
Now can you do the second one?
Yeah.
Now check, calculate the mass. Now we need mass following amounts. So amounts are given, moles are given, right?
Yeah.
So the formula for that is m is n into capital M, where m is the molar mass. So check, we have been given mole, so n is given to us. That is 0.8. And molar mass, can you calculate for hydrogen peroxide?
Yeah.
Okay, so you solve A, C, and E.
Okay. Okay, so for the mass of it, I got 34.
Correct. That's correct. So unit is gram per mole.
Yeah.
Now can you calculate the mass?
Yeah. I got 27.2.
That's correct. So now if you see, there are only two significant figures over here,
Yeah.
right? So the answer is 27 grams.
Okay.
Okay, you have studied about significant figures, right?
Yeah. We did.
Okay, so anything before the decimal is irrelevant,
Okay.
right? So only the numbers after decimal. Okay, let me tell you this. So if it is 0.008, these are irrelevant. Okay,
Okay. Yeah.
anything after that zero you count for the significant figures.
Okay.
Okay, so this is the most difficult part in significant figures, right?
Yeah.
Okay, can you do the mass?
Yeah.
So you did that, right? Now do the
Yeah.
C. What is milli? This is millimole. Milli means I told you divide by 1000,
Okay.
correct?
Yeah.
Yeah.
Okay, I finished.
C as well as E?
Yeah. No, I did C. Should I
Okay,
do E too?
0.50.
Yeah.
Okay, that's good. Then yeah, do E. Again,
Okay.
check 45 millimole. Millimole means divide by
Um.
1000.
Okay, divided by 1,000.
Yeah, so you need like try to remember this concept. If it is M before a unit, that means it is divided by 1000. If it is K before a unit, it means it is multiplied by 1000.
Okay.
Okay.
Yep. Do you think you can like scroll back up for a second? I forgot to write the numbers here. Okay, I finished.
Okay. That's done, right?
Yep.
Now let us come to the new concept, that is determination of moles if number of entities are given to you. Okay.
Okay.
So number of entities means a count is given to you, and
Okay.
from that you can determine the moles. But for that the formula is N is N over capital Na. So that
Okay.
is capital N over Na, right?
Yeah.
So the triangle for that is N is N over Na, where Na is a constant, right?
Yeah.
And the number is 6.022 into 10 raised to 23.
Yep.
Okay,
Yeah.
so can you copy this? So
Yeah. Yep.
the meaning of N is clear to you. And
Yeah.
moles, you also know moles can be determined using the other formula, that is N is equal to M over M and M is equal to N into M. Correct?
Yeah.
So this also can be determined if you know it is for what entity. Correct?
Yeah.
So if they give you calcium carbonate, you can determine the N.
Okay.
Okay.
Yep.
Have you copied the formula?
Yeah, I'm writing it down right now.
Okay.
So do I just write down Na equals to 6 point?
Yes, please write down
Okay.
that. That is what is the concept. That exactly is the mole concept.
Okay.
The first part that we did now and this part, that forms the basics for all the further units.
Okay. I wrote it down.
Okay. Is okay. The formulas are clear?
Yeah.
Okay, now let us try to solve these problems. Okay.
Okay.
Now check. A typical car battery contains 8.16 kg of lead. Kg, can you see the unit?
Yeah.
So kg means what is given to us? Mass.
Yeah.
Correct?
Yeah.
Typical car battery contains 8.6 kg of lead. So
Yeah.
you know what it is.
Yeah.
You know the mass. If you know the what, you know the capital M.
Okay.
Correct? If you
Yeah.
know the mass and M, you know the N. So now here they have not directly given you the, like in the previous problem, they were telling you moles, calculate the mass. Right?
Yeah.
Here what they did, they give you the mass. They gave you what it is. Now they are asking determine the number of lead atoms.
Okay.
Correct? So
Yeah.
now we have to use two formulas. So the way I deal with such problems, if mass is given to us, correct?
Yeah.
We have to determine the moles. And how to determine the moles from mass? We divide by the molar mass. And once we have the n, then we have to determine the number of entities. Here they are asking us number, correct?
Yeah.
We have to determine the n. How do we get that? N from the small n, the capital N, how do we get? We have to multiply by the Avogadro's number.
Same.
Can you try it? The first one.
Yeah. Actually, can I have like some help with that question?
For this question,
Yeah.
okay, do you have the mass 8.16 kg?
Yeah.
Can you calculate the moles?
Yeah.
Do you know the
And
molar mass of lead?
207.
Yeah, so can you calculate the N?
Okay. Is it 39.4?
Okay,
Like,
so you got 8160, 8,
yeah.
right?
Yeah.
8160 divided by two
Mm,
zeros.
7.
So
Yeah.
you got 39.4.
Yeah.
That's fine. So now, what is Na?
39.4.
N is 39.4,
Yeah.
right? What is Na?
Um, is it 8,160?
No, it is 6.022 into 10 raised
Oh,
to 23. The Avogadro's
mm,
number.
okay. Mm.
Have you made a note of this?
Yeah, I just forgot. That's wrong. Okay. 6.022.
Into 10 raised to 23 is Na.
Yeah. Yeah. Okay.
Okay. So
Yeah.
did you get the N?
1 sec. Is it 2.3 7 times 10 to the power of 25?
That's the answer, yes.
Okay.
Okay, can you do now second?
Yeah.
Check the mass is given to you.
Mm, mm,
And it is given what item it is. Carbon. So mass
yeah.
is known to you, carbon is known to you, so you know the molar mass, you can find out N.
Okay.
So same rule as the previous one.
Okay.
Sorry.
I got 1 times 10 to the power of 22.
Yeah. Do the third one.
Okay.
Okay. Have I covered the entire thing? You were having some doubt from your previous unit.
Um, should I like show you like the worksheet that he gave us?
Yeah, sure. I'll stop sharing.
Um, like this
Yeah.
one. So this is like the worksheet he gave
Can
us.
you zoom, like expand it?
Yeah, um,
Yeah, maximize it. Yes.
there's something in like it's like
Yeah.
this one.
Yes.
So I think we covered. I think we did this part actually.
Yeah. Okay. Now we covered this, and now the second part we were covering was the n is equal to na, right?
Yeah.
So, okay, let us, then there is one more concept that I want to cover,
Mm-hmm.
okay, which most of the student have struggled with, okay, and it will not be only you. I can even if you struggle, it's not a surprise, okay. Where will be? Yeah, here. Okay, so
Am I still
this
screen sharing?
yeah, this concept is clear to you, right? Whatever we did so far, that was clear.
Yeah.
There is one concept that I want you to know is that difference between molecules and atoms. Do you
Okay.
know difference between molecules and atoms?
Mm, yeah. Yeah.
What is it?
Atom is one, and molecule is combined
Okay, yes,
atoms,
molecule is
combined
combined.
atoms.
Okay, yes. So for example, if I have been given, let us say, C2H6. Okay,
I can't see. I don't think I can see your screen.
I'm sharing my screen, not able to see it yet.
No. Wait.
Oh, you stop sharing your screen, please.
Oh. Okay.
Can you see my screen?
No, wait one sec. How do I stop sharing it? I don't.
There must be an access over there. Just close that.
Oh, wait. Okay.
Yeah.
Okay, I think I stopped sharing.
Now can you see my screen?
Oh yeah, I can see it.
Yeah. So uh, what I was saying was, if you see C2H6, right? This is a molecule,
Yeah,
correct?
yeah,
If you have n of this, right?
yeah,
So let us say you have been given the mass of this atom or this element. Sorry, my bad. This molecule, right?
mm,
So
yeah,
you know the molar mass of this molecule, correct?
yeah,
You will get the moles of the molecule,
yeah,
correct?
yeah,
If you get n, right, then
yeah,
you can find out the n by dividing it by Na,
yeah,
correct?
yeah.
But when you do that, you will get n of molecules. So remember this, if mass of molecule is given,
Okay.
okay,
Yeah,
you are using m of molecule, you get n for the molecule, that is moles of molecule, correct?
yeah,
And if you divide by the Avogadro's number, you get capital N for the molecule,
yeah,
okay?
yeah,
At times what happens, the question gets extended and they ask us N for atoms. So in this case, they might ask us carbon. So each molecule is having how many carbon?
two.
So you will multiply this N of molecule by that specific number.
Okay,
Then you will get the N for the atoms.
okay,
Okay. If they ask us for hydrogen, so here we multiply by 2, here we will multiply by 6.
okay,
Okay. Is this understood?
yeah,
Can you please write down this?
yeah. Do I write down like everything?
Yes.
Okay,
So what you need to write down, if if mass of molecule is given, if molar mass of molecule is calculated, then you get N of molecule.
okay,
If you divide it by the Avogadro's number, you get N, capital N, for the molecule. Then if you need the atoms, you need to multiply. And the reverse is also true.
okay. I wrote it down.
Okay, and then the reverse is also true.
Okay,
That if you divide the number of atoms by the X in the molecule, you will get number of molecules. If you
okay,
get the molecules, multiply by the Avogadro's number, you will get the moles.
okay.
Correct?
Yep,
Oh, my bad, my bad, my bad. I think I made a mistake. This is multiply
yeah,
and this is divide. Please correct that. I'm so sorry.
yeah,
Okay.
yeah.
So we'll stop here and we'll continue in the next class. Okay.
Okay,
Okay. Bye.
okay, bye.